Hi, this is the next in my series of videos, and I just want to make a couple of announcements. First, uh, it has been a while since I've done some videos. I will be doing more, and I will be setting things up so it'll be easier to see no matter where you're from. I do now have access to YouTube at school, and we will be talking about how you can watch the videos on your phone at school and at home. I'll still be doing it in Vimeo, also, so that if you're at a school computer, you'll be able to use the school computer to see the videos. So, let me talk briefly about a subject that a lot of people are still a little bit, not quite 100% getting just yet, and that is the velocity versus time graphs. And this is a hard one, at least initially. So, here's what we did in class on this. I gave you a position versus time graph, or I gave you a description, and I'll get a better looking one here in a second. That's actually really sad. Let me erase that and try this again. Okay, so we'll start with a, oh, what happened there? There we go. We'll start with a position versus time graph, and let's say there's our straight line. And I said that if this is position and this is time, you might remember that this position versus time graph, if that's a straight line, then that straight line gives us the slope, which is our position divided by time. And if you remember the units for that, that's meters divided by seconds. And the way we will usually say this, you'll hear us saying meters per second. You do this all the time in your cars if you're driving along and you're going miles per hour. And it's a distance divided by time, which is our velocity. Now here's another little thing I'm going to do on these when I'm drawing it. That's telling us it's a vector. Remember, a vector has a size plus a direction. And this direction would be a positive direction. If I had another one going this way, that would be a negative direction. So because I can get a positive or a negative direction on this, this is a vector. So this slope is our velocity. And if we do the full equation here, we'll have our displacement, or our distance, is equal to velocity times time plus whatever our initial distance was. Well, this velocity is constant. It's not going to change in this situation. It's the same slope here, here, here. So if we plot that on a graph, at any one particular time, if this is my velocity, this will be the velocity, that'll be the velocity, that'll be the velocity, that'll be the velocity. I haven't done any kind of numbers here, and this gives me a nice horizontal line. This velocity time graph is going to do some interesting things for us later on. Sometimes you'll be given the velocity versus time graph, and then you'll have to figure out what the position versus time looks like. Or you'll have to just find out how far it went. And we will get to those later on in the class. I just want to show this using Excel. These were some really ugly hand-drawn things, but now I'm going to use Excel. And what I did here is I've got some data, position versus time, that I know ahead of time is a straight line. I'll insert my chart. There we go. It'll be that kind of scatter chart. I'll put in my trend line. Remember, to put in a trend line using Excel, you right-click on the dot, any dot, doesn't matter which one, add a trend line. Now, depending on your version of Excel, this will either show up right away, or you'll have to click on another button, tab to get to where it says Display Equation on Chart. I'm going to be very careful about setting the intercept. Right now, I'm not going to do that. And notice my equation on the chart is y equals 3x plus 1. Okay, Now that 3 is our velocity, and it's going to be our velocity all the time. So I'm going to make another data set, and let's imagine again that I have these times. I'll just copy these times. And then what's my velocity? Well, coming back to this, it was 3. And it was 3. And it was 3. I'm just going to copy that velocity all the way down. And I'll let Excel draw the graph this time. Insert, my chart, right there. You'll notice right here, this is our trend line. It's linear. I'll display the equation on chart. It definitely won't set the intercept here because you can kind of see it's not going to intercept anywhere near 0. Of course, I could in Excel just say my intercept is 3, but I'll just let this thing do that for me. There's my equation, hard to see now. There, y equals 3. So this is a constant velocity. And that's what any constant velocity will look like. If I change the number for the velocity, we'll change where this thing is showing up. Let me change this to -3. That's going to kind of make that look ugly, but I'll just copy and paste this. Now notice it's below the line. It's at -3. What if our velocity is 0? It's standing still. Where does that go? There it is, right there at 0. It's standing still. If you do have a copy of Microsoft Excel, go ahead and play around with some constant velocities. You'll see that a constant velocity is always horizontal. No matter what number you give it, Excel will plot it at the right point. And the nice thing is to see the equation. Y is just some constant number. Okay, that's all I have for right now. Let me know what you thought of this video. I will give credit to you for having seen it. All you have to do is go to Edmodo, click on Turn In, and just type anything in the box that says you've seen it. I'm not going to even ask you a question on this. So just click on the Turn In button. This is important for me that you've seen it. Basically, I want to know that you were able to, either on your phone or at school, see this video. Okay, thank you very, very much for your time, and may all your problems have solutions.